Okay, this is an example which is based on a question from a past paper. Again, it involves the first derivative and the second derivative. It gives us a curve y equals 8 times the square root of x, and we want to show that dy by dx all squared, so in other words the first derivative all squared plus y times the second derivative is equal to 0. So what we're going to do then is we're going to differentiate the curve to get an expression for dy by dx. We're then going to differentiate again to get the second derivative, d2y by dx squared, and we're basically going to sub those two expressions into this equation and show hopefully that it equals 0, or that it gives 0. So first of all, we have our curve. We can't differentiate yet because there's a root in it, so let's rewrite it without the root. So that's 8x to the power of a half. So let's differentiate and get dy by dx. So dy by dx, so multiply by the power, we're going to get 4, copy down x, and then subtract 1 from the power. What we could do now is we could bring x to the bottom line and just make it positive, so that would be 4 over x to the power of positive a half. Okay. You could go a bit further and you could put the root in and write it as 4 over the square root of x. We'll do that as well. And that's perfectly okay. And I'm going to call that equation 1 if you like. So that's number 1, or we'll call it A. Call it A. So that's what dy by dx is. So very shortly, we're going to replace dy by dx in our given equation here with 4 over root x. What we're going to do now is get another equation or expression for d2y by dx squared. So in order to do that, we have to differentiate dy by dx. So we're going to get the second derivative, d2y by dx squared. So second derivative is found by differentiating the first derivative. So again, we're going to multiply by the power. So minus a half multiplied by positive 4, well, it's going to be a negative. And a half times 4 is just 2. Copy down x, and then subtract 1 from the power. So it's going to be minus 3 over 2. Again, I'm going to bring x to the bottom line. So that's going to give us minus 2 all over x to the power of positive 3 over 2. Remember to change the sign of x when you move it to the bottom line, the sign of its power. Again, we could write it in root form, so we could write that as minus 2 over the square root of x cubed. And leave it like that. And what I'm going to do is I'm going to call that b. So with a and b, we've now worked out equations, or if you look at the right hand side of each, an expression for the first derivative and the second derivative. Okay, so second derivative, first derivative. So what I'm going to do now is I'm going to sub a and b into the left hand side of the given equation. So let's sub a and b into the left hand side of the given equation. So if we go back to what we're given, we've got dy by dx all squared. So dy by dx is 4 over root x, so sub it in, we're going to get 4 over the square root of x, and that's all being squared. And then go back again, plus y, so y is 8 root x, remember? So plus 8 root x, and then that's being multiplied by d2y by dx squared, the second derivative. So we're going to chuck in the second derivative, which is now that. Okay, so that's what we've got. So we want to show that this all boils down to 0. So let's square the first one. Well, square 4 we get 16. Square root x we just get x. So that's going to give us 16 over x. Okay, over here then. So multiply the top bits together. So we're going to get minus 16 root x. And that's all over root x cubed. Now, let's tidy it up. So what do we have? We've got x to the power of a half here, and we've got x to the power 3 over 2. So if I were to take our top line, that root x is x to the power of a half. And this root x cubed is the same as x to the power of 3 over 2. So we're dividing with two indices with the same base, so we're subtracting their powers. So that's going to give us 16 over x. And we are subtracting, and again we've got 16. X to the power of a half minus x to the power of 3 over 2 is going to give us x to the power of minus 1. A half minus 3 over 2 gives you minus 1. I'm now going to slide that x to the bottom line. So that's going to give us 16 over x. And then we're subtracting 16 over x to the power positive 1. So 16 over x minus 16 over x is just going to give us 0, hence shown. Okay, so good little example there involving the first and the second derivative.